Moving on to the fourth bit, the given equation is 2x square minus x plus 1 by 8 is equal to 0. This equation can be written as, by taking the LCM as 8, this becomes 8 times of 2x square is 16x square, 8 times of minus x is minus 8x, plus 1 is equal to 0. So 16x square minus 8x plus 1 is equal to 0. The product of the first term and the last term is 16x square. We need two terms such that their product must be equal to 16x square and their sum must be equal to minus 8x. 4x and 4x. The product will be 16x square, and if I put a minus sign here, their sum minus 4x and minus 4x will be minus 8x. So minus 4x and minus 4x will satisfy both the conditions. 16x square minus 4x plus 1 is equal to 0. 4x can be taken as common from the first and second terms. 4x times of 4x minus 1, and minus 1 can be taken as common from the third and fourth terms. Minus 1 times of 4x minus 1 is equal to 0. Now taking 4x minus 1 as common, and the remaining terms will be 4x minus 1. This is equal to 0. We can write 4x minus 1 is equal to 0 and 4x minus 1 is equal to 0. 4x is equal to 1 and here also 4x is equal to 1. Therefore x is equal to 1 by 4 and x is equal to 1 by 4. Therefore this equation has the repeated roots which are 1 by 4 and 1 by 4. Coming to the second problem, solve the following problems. The first bit given is, John and Jivanti together have 45 marbles. Both of them lost 5 marbles each, and the product of number of the marbles now they have is 124. We would like to find out how many marbles they had to start with. Let us see the solution. Initially, assume number of marbles John had is equal to x. Totally John and Jivanti together have 45 marbles. So number of marbles Jivanti had is equal to total number of marbles minus number of marbles John had. Total number of marbles is 45 and number of marbles John had is x. So number of marbles Jivanti had will be 45 minus x. Now both of them lost 5 marbles each. So number of marbles John had after losing is equal to x minus 5. Number of marbles Jivanti had after losing is equal to 45 minus x minus 5. This becomes 40 minus x. Now according to the given condition, product of the number of marbles they now have is 124. So this product x minus 5 times of 40 minus x will be equal to 124. This can be written as x times of 40 minus x minus 5 times of 40 minus x is equal to 124. 40x minus x square minus 200 plus 5x is equal to 124. Minus x square plus 45x minus 200, and 124 can be transposed to LHS and this becomes minus 124
is equal to 0. Minus x square plus 45x minus 324 is equal to 0. This can also be written as x square minus 45x plus 324 is equal to 0. Now the product of the first and last terms is 324x square. We need two terms such that their product must be equal to 324x square and their sum must be equal to minus 45x. Let us take 36x and 9x. The product of them is 324x square and the sum will be plus 45x. But here we have minus 45x. So if we put a minus sign here, then we get product as 324x square and the sum will be minus 45x. So minus 36x and minus 9x will satisfy the two conditions. X square minus 36x minus 9x plus 324 is equal to 0. Now taking x as common from the first and second terms, we get x times of x minus 36, and here we can take minus 9 as common. Minus 9 times of x minus 36 is equal to 0. X minus 36 can be taken common. The remaining terms will be x minus 9, which is equal to 0. This can be written as x minus 36 is equal to 0 and x minus 9 is equal to 0. So x is equal to 36 and x is equal to 9. Initially we assumed the number of marbles John had is x. If John had 36 marbles, Jivanti will have 9 marbles. If John had 36 marbles, Jivanti would have 9 marbles. If John had 9 marbles, Jivanti would have 36 marbles. So this is the solution of this problem. Coming to the second bit, a cottage industry produces a certain number of toys in a day. The cost of the production of each toy in rupees was found to be 55 minus the number of toys produced in a day. On a particular day, the total cost of production was 750 rupees. We would like to find out the number of toys produced on that day. Let us see the solution. Assume the number of toys produced in a day is equal to x. Number of toys produced in a day is equal to x. Now the cost of the production of each toy is equal to 55 minus number of toys produced in a day. Cost of production of each toy is equal to 55 minus number of toys produced in a day is x. So this becomes 55 minus x. Total cost of production is nothing but number of toys produced in a day multiplied by cost of production of each toy. So total cost of production becomes x times of 55 minus x. According to the given problem, total cost of production is equal to 750 rupees. We can write x times of 55 minus x is equal to 750. On multiplying, we get 55x minus x square is equal to 750. So transposing the terms on the left hand side to the right hand side, we get x square minus 55x plus 750 is equal to 0. Now The product of the first term and the last term is 750x square. We need two terms such that their product must be equal to 750x square and their sum must be equal to minus 55x. Let us take 25x and 30x. 25x multiplied by 30x is 750x square. 25x plus 30x is 55x. Here we have minus 55x. So if we put a minus sign here, we get the sum as minus 55x and the product as 750x square. So minus 25x and minus 30x satisfy both the conditions. So we can replace minus 55x with minus 25x and minus 30x. So this is plus 750 is equal to 0. X can be taken as common from the first and second terms. We get x minus 25, and here minus 30 can be taken as common. So this becomes x minus 25 is equal to 0. X minus 25 can be taken common and the remaining terms will be x minus 30. This is equal to 0. We can write x minus 25 is equal to 0 and x minus 30 is equal to 0. So x will be 25, also x will be 30. Here we need to find the number of toys produced on that day. The number of toys produced on that day, number of toys produced is equal to, it can be either 25 or 30. Coming to the third problem, find two numbers whose sum is 27 and product is 182. So let us assume one number is equal to x. Since the sum of the two numbers is 27, the other number will be, total sum is 27 minus one number which is x. So the other number would become 27 minus x. And the product of the two numbers, which is x times of 27 minus x, it is given as 182. So on multiplication we get 27x minus x square is equal to 182. Now transposing the terms on left hand side to the right hand side, we get x square minus 27x plus 182 is equal to 0. The product of first and last terms is 182x square. So we need two terms such that their product must be equal to 182x square and their sum must be equal to minus 27x. Let us take 13x and 14x. So 13x multiplied by 14x is 182x square. 13x plus 14x will be 27x. Here we have minus 27x. So we need to put minus 13x and minus 14x. Now their sum will be minus 27x and their product will be 182x square. So minus 13x and minus 14x satisfy both the conditions. So replace minus 27x with minus 13x and minus 14x plus 182 is equal to 0. X can be taken common from the first and second terms. X minus 13 will be remaining and minus 14 can be taken common. X minus 13 will be remaining. This will become 0. X minus 13 can be taken common and the remaining terms will be x minus 14. This is equal to 0. We can write x minus 13 is equal to 0 or x minus 14 is equal to 0. This gives x is equal to 13 or x is equal to 14. Therefore, the two numbers are 13 and 14. Coming to the fourth problem, find two consecutive positive integers sum of whose squares is 365. So let us see the solution. Assume one positive integer as x. So one positive integer is equal to x. The consecutive positive integer becomes x plus 1. According to the given condition, the sum of the squares of the two consecutive positive numbers is 365. So square of the first positive integer is x square and the square of the consecutive positive integer is x plus 1 whole square. So this is given as 365. So this can be written as x square, and x plus 1 whole square can be expanded as a plus, we know that a plus b whole square is equal to a square plus 2ab plus b square. By using this identity, we can expand x plus 1 whole square, and this becomes x square plus 2x plus 1 is equal to 365. X square plus x square is 2x square, and this is 2x plus 1. This is equal to 365. 2x square plus 2x plus 1, and 365 can be transposed to left hand side, and this becomes minus 365 is equal to 0. 2x square plus 2x plus 1 and minus 365 is minus 364, which is equal to 0. Now 2 can be taken common. X square plus x minus 182 is equal to 0. So the equation becomes x square plus x minus 182 is equal to 0. Now the product of the first and last terms is minus 182 x square. So we need two terms such that their product must be equal to 182 x square and their sum must be equal to plus x. Let us take 13x and 14x. 13x multiplied by 14x is plus 182 x square, but here we have minus 182 x square. So if we put a minus sign here, minus 13x multiplied by 14x is minus 182 x square, and sum minus 13x plus 14x is plus x. So minus 13x and plus 14x satisfy both the conditions. So replace x with minus 13x plus 14x minus 182 is equal to 0. X can be taken common from the first and second terms. We get x minus 13, and plus 14 can be taken common from third and fourth terms, and here we get x minus 13 is equal to 0. So x minus 13 can be taken common. The remaining terms will be x plus 14, which is equal to 0. We can write x minus 13 is equal to 0 or x plus 14 is equal to 0. This becomes x is equal to 13 or x is equal to minus 14. In the question, we need to find two consecutive positive integers, but here we got x is equal to minus 14. This is not a positive integer, so x is equal to minus 14 can be ignored. So take x is equal to 13 into consideration. So one positive integer will be 13. The consecutive positive integer is x plus 1, which is 13 plus 1, nothing but 14. So the two consecutive positive integers are 13 and 14. Moving on to the fifth problem. The altitude of a right triangle is 7 centimeters less than its base. If the hypotenuse is 13 centimeters, find the other two sides. So let us see the solution. Given that altitude of the right triangle is 7 centimeters less than its base, so assume base of the right triangle is x centimeters. So altitude becomes x minus 7 centimeters. Also, hypotenuse is given as 13 centimeters. Hypotenuse is 13 centimeters. In a right triangle, we know that base square plus altitude square is equal to hypotenuse square. Base is x, so base square is x square, and altitude square is x minus 7 whole square, and the hypotenuse square is 13 square. So x square plus x minus 7 whole square can be expanded as x square minus 14x plus 49, and 13 square is 169. So this is 2x square minus 14x plus 49, and 169 can be transposed to left hand side and it becomes minus 169 is equal to 0. Now 2x square minus 14x plus 49 and minus 169 is minus 120, and this is equal to 0. So 2 can be taken common. X square minus 7x minus 60 is equal to 0. So the equation becomes x square minus 7x minus 60 is equal to 0. So the product of the first and last terms is minus 60 x square. We need two terms such that their product must be equal to minus 60x square and their sum must be equal to minus 7x. So let us take 12x and 5x. 12x multiplied by 5x is 60x square, but here we have minus 60x square. If I put a minus sign here, now the product becomes minus 60x square, and the sum minus 12x plus 5x is minus 7x. So minus 12x and plus 5x satisfy both the conditions. So minus 7x can be replaced by minus 12x plus 5x, and here we have minus 60. This is equal to 0. X can be taken common, remaining will be x minus 12, and 5 can be taken common and remaining will be x minus 12 is equal to 0. Now x minus 12 can be taken common, the remaining terms are x plus 5. This is equal to 0. So x minus 12 is equal to 0 or x plus 5 is equal to 0. So x can be 12 or x can be minus 5. Since x is a length, it can never be negative. So x is equal to minus 5 can be ignored. So x is equal to 12. That is, base is equal to 12. And altitude is x minus 7, which is 12 minus 7, that is equal to 5 centimeters. So base is equal to 12 centimeters and the altitude is 5 centimeters. Moving on to the sixth problem. A cottage industry produces a certain number of pottery articles in a day. It was observed on a particular day that the cost of production of each article in rupees was 3 more than twice the number of articles produced on that day. If the total cost of production on that day was 90 rupees, find the number of articles produced and cost of each article. So let us see the solution. Assume number of articles produced on that day is equal to x. Number of articles produced is equal to x. Cost of production of each article is equal to 3 more than twice the number of articles produced. So we can write cost of production of each article is equal to 3 more than, that means 3 plus twice the number of articles produced. Twice the number of articles produced is 2x. So cost of production of each article becomes 3 plus 2x. Now the total cost of production, so total cost of production can be written as number of articles produced multiplied by cost of production of each article, which is x multiplied by 3 plus 2x. According to the given problem, total cost of production is given as 90 rupees. So this is equal to 90. So this becomes 3x plus 2x square is equal to 90. We can write 2x square plus 3x, and plus 90 can be transposed to LHS, and this becomes minus 90 is equal to 0. Let us solve this equation by the method of factorization. The product of first terms and the last term is 180x square. We need two terms such that their product must be equal to 180x square. This is minus 180x square. And their sum must be equal to plus 3x. So we can take 15x and 12x. So 15x multiplied by 12x is plus 180x square. But here we have minus 180x square. So we can put minus sign here or here. If we put minus sign here, 15x minus 12x is plus 3x. So 15x and minus 12x satisfy both the conditions. 3x can be replaced with plus 15x minus 12x, and here we have minus 90. This is equal to 0. So x can be taken common. This is 2x plus 15, and here minus 6 can be taken common, and we'll be getting 2x plus 15. So this is equal to 0. So 2x plus 15 can be taken common. The remaining terms will be x minus 6. This is equal to 0. So 2x plus 15 is equal to 0, or x minus 6 is equal to 0. So we get x is equal to minus 15 by 2, or x is equal to 6. X is the number of articles produced. Since it can never be negative, so this value can be ignored. So this can be taken into consideration. Therefore, number of articles produced is equal to 6, and the cost of production of each article is equal to we got it as 3 plus 2x. We know that the value of x is 6, so 3 plus 2 times of 6. This is equal to 3 plus 12, which is 15. Therefore, the number of articles produced is 6, and the cost of production of each article is 15.